I'm Adam Lawson from the Ontario Science Centre. There's a good chance you've heard of the term climate change or global warming at some point in your life. Most of us are aware that climate change is negatively affecting our planet, and understanding the science behind it can give us a better perspective on what's happening to our Earth and what we can do to reduce the effects of this phenomenon. Whew, it's getting pretty hot under there. Climate change is caused by an increase in the amount of greenhouse gases in our atmosphere. Now you're probably wondering, why am I wearing all these blankets? Well, just as these blankets trap the heat from my body, the greenhouse gases in our atmosphere, such as carbon dioxide, trap the heat from the sun, making our planet warmer. As more carbon dioxide enters our atmosphere, the Earth becomes even more warm. Now that's just like me putting on another blanket. Sure is getting toasty now. The main source of carbon dioxide in our atmosphere comes from human-induced activities. This includes the burning of fossil fuels, so that's coal, oil, and gas, and deforestation. This increase in the emission of fossil fuels is negatively impacting our oceans as well. Oceans and other large bodies of water absorb much of the excess carbon and thus heat in our atmosphere. While this process is undoubtedly beneficial for Earth's surface temperature, it's negatively impacting our oceans. This negative impact is known as ocean acidification, which is altering the chemistry of our oceans and the marine wildlife within them. Today, we'll be performing an experiment to demonstrate the effects of ocean acidification. We'll be using everyday materials found at home, such as these, and if you don't have them, you can pick them up at your local supermarket. For this experiment, you'll need red cabbage juice, vinegar, baking soda, 2 large clear plastic containers. In this case, I have 2 empty peanut butter containers, 2 paper cups, tape, plastic wrap, a measuring cup, and a measuring spoon. Let's start with the red cabbage juice. You can make it at home by mixing chopped red cabbage with boiling water or breaking it down with water in a blender. Instructions on how to create your own red cabbage juice are listed in our Grade 10 Acids and Bases chemistry video and Acids and Bases companion guide. The link to both sources has been provided below. Now that you have your cabbage juice, it needs to be diluted. Mix 100 milliliters of water with just 1 tablespoon or 15 milliliters of cabbage juice. Pour this mixture into one of your large plastic containers, and then repeat this process for your other large plastic container. Once again, that's 100 milliliters of water and 1 tablespoon of cabbage juice. Now that you have cabbage juice in both of your large plastic containers, you're going to take a paper cup and tape it on the inside of your plastic container. All you need for this is 1 piece of tape. Put it on the inside of the cup with a bit sticking out. Place the cup inside and tape right around the edge. And then you're going to do this with your other paper cup as well inside of the other container. Now it's very important when you do this that you don't get the bottom of either cup wet. They should be in the container but not touching the cabbage juice. Into one of our cups, we're going to add 2 milliliters or half a teaspoon of baking soda. And then we're going to add 1 full teaspoon of vinegar. Now the paper cups I'm using are rather large, but when you do this, make sure both of these substances go in the paper cup and not the cabbage juice. As soon as I pour this vinegar in the cup, I'm going to quickly take some plastic wrap and put it right on top of the plastic container to make sure I contain all the gases inside. And something I'm going to do because I have the lids is put the lid on both containers. Now this isn't necessary, it just helps me hold everything in place for our experiment. And there you have it, you've completed the experimental setup. Take a picture with both cups in it and wait for 10 to 15 minutes. At this point, you should pause the video and try the experiment for yourself. Now that 15 minutes have passed, let's make some observations about our experiment. Did the cabbage juice change color in both containers? If so, what color did it change? In which container did we add the baking soda and vinegar? Did you notice a color change in that container? Also, why did we put cups in both of our containers? Here I have an example of the completed experiment. You'll notice that one of the containers of cabbage juice has remained bluish purple, while the other has changed violet. Let's explore why this change has occurred. Red cabbage juice changes color in the presence of an acidic or basic solution. We call this type of substance an indicator of potential hydrogen, or pH, because acids and bases are characterized by the amount of hydrogen ions within a solution. Hydrogen ion concentration is measured using the pH scale, which we'll look at now. Looking at the pH scale, you'll notice that the number in the middle is 7. Solutions with a pH of 7 are neutral, meaning they're neither acidic or basic. Water is an example of a chemical compound with a pH of 7. Solutions that are acidic have a pH less than 7, and solutions that are basic have a pH greater than 7. The more acidic a solution, the lower the pH value will be, all the way down to a value of 0, and the more basic a solution, the higher the pH value will be, all the way up to a pH value of 14. When setting up our experiment, the cabbage juice in both of our containers had a pH of 7, as it was heavily diluted by water. After 15 minutes, the cabbage juice in one of our containers changed color, indicating a change in pH. Based on this image, do you think the cabbage juice in your experiment became more acidic or became more basic? If you said acidic, you're correct. But how did this acidification occur? No substances were added to the cabbage juice directly. While this statement is true, the pH of a solution can also be altered by surrounding gases. Remember the vinegar and baking soda we added to one of the cups? They reacted according to this chemical formula. Vinegar plus baking soda react together to form carbon dioxide, water, and sodium acetate. After 15 minutes, 3 new chemical compounds are formed, one of which, carbon dioxide, is a gas which has filled the inside of the container. Just in case you're wondering about the other 2 compounds, sodium acetate and water are mostly within the cup inside of one of the containers. Once the carbon dioxide gas within the container mixes with the water in the cabbage juice, it forms carbonic acid, according to this chemical equation. Water plus carbon dioxide react together to form carbonic acid. As you might have guessed, carbonic acid is acidic, and it has decreased the pH of the cabbage juice in one of the containers, changing its color from purplish blue to violet. The other container did not change color as no carbonic acid was produced inside of it. This is our control, which represents the color of cabbage juice in a neutral solution with a pH of 7. Now that we understand the results of our experiment and we know there's carbonic acid within this cabbage juice, let's extend what we've learned to the state of the world's oceans. As mentioned earlier, oceans are kind of like a massive worldwide carbon sponge, or what scientists call a carbon sink. They absorb the extra carbon dioxide that enters the atmosphere through human activity, such as burning fossil fuels in our factories and cars. While this absorption means that the Earth does warm up a bit more slowly, it also changes the chemistry of ocean water. The extra carbon dioxide reacts with the ocean water to form carbonic acid, lowering the water's pH. This acidification of our oceans began close to 275 years ago, when humans began burning large amounts of fossil fuels. Since then, the world's oceans have become 30% more acidic. This phenomenon is very similar to the change in pH that occurred during our cabbage juice experiment, but on a much larger scale. At this point, it's quite clear that our oceans are becoming more acidic, but how does this acidity affect marine organisms, or even us? Firstly, many marine organisms are now struggling to form strong and stable seashells. As levels of carbonic acid in the ocean increase, levels of carbonate, a naturally occurring base in the ocean, decrease. Prior to acidification, much of the oceanic carbonate was free to react with calcium and form calcium carbonate. Calcium carbonate is a compound used by marine organisms to create seashells and corals. With more acidification, there's less free carbonate in the ocean as much of it reacts with hydrogen ions produced through acidification, forming bicarbonate. This decrease in oceanic calcium carbonate results in the formation of weaker shells and coral, structures that many marine organisms depend on for their survival. If organisms can't build strong enough shells or coral, how do you think that will alter their ability to survive? Here's another thing to consider. Coral is not only affected by ocean acidification, but increasing temperatures due to global warming as well. As the temperatures of the ocean increase, coral becomes stressed and loses its symbiotic algae in a process known as bleaching. Without this algae, the bleached coral is much more susceptible to disease. Ocean acidification compounds this issue by causing bleached coral to regrow at a reduced rate after structural damage due to disease. Healthy coral reefs are home to many marine species. When the reefs die, what happens to these species? What happens to the people who depend on these species as a food source? As mentioned earlier, most of the carbon dioxide that eventually ends up in our ocean is a result of human activity. In Ontario, the majority of carbon emissions are caused by gasoline and diesel-powered transportation, factories, and heating buildings. Fossil fuels include coal, crude oil, natural gas, and gasoline. Our reliance on fossil fuels is having an enormous impact on the health of our planet. So what can you do? The good news is you have options. It can be as easy as choosing to take the bus, ride a bike, or carpool to cut down directly on fossil fuel consumption. Adjust the temperature in your home to save more energy. Set the thermostat a degree or two cooler in the winter and wear a sweater. Let your house be a bit warmer in the summer and use a fan. Reducing, reusing, and recycling also shrinks your carbon footprint. So shop for used clothes at a thrift store. Or, if you need to update your electronics, look for something pre-owned online. But one of the biggest gestures you can make is to speak up. Have conversations with family, friends, and local representatives about practical and simple choices you can make to protect our world's oceans. Search out and support not-for-profit organizations that are also working towards this kind of change. Luckily, it doesn't matter whether you live close to an ocean or far away. Your choices, even the smallest ones, can make a difference. Today, we learned that atmospheric carbon dioxide is entering our oceans, making them more acidic. Using a simple at-home experiment, we then discovered how carbon dioxide in the atmosphere is entering the oceans below. Now I leave it up to you to see how you can alter the experiment. What would you change? Here's a fun suggestion. Put eggshells inside of the cabbage juice in both of the containers to mimic seashells and coral. Make sure you include a control and take a photo every 5 minutes. Once you have your results, share them with us. We'd love to see them on our social media channels. For more ideas, you can check out our companion document. The link is posted below. Have fun exploring science at home using everyday materials. Thanks for watching.